Hello again. This is an introduction to computer hardware. This is part of the first webinar series, Webinar 1, in which we want to provide an overall foundation to computer technology. It is my goal during this presentation to give you an introduction to computer hardware. My main goal, even though at times it may be technical, my main goal is to really afford you the ability to recognize what computer hardware is, to get a basic understanding of how it functions, to appreciate what we may need to seize in the event that we're conducting an investigation and we're suspecting that something may contain data that could provide evidence in our investigation. So that's the overall goal. Please keep this in the back of your mind as we proceed through the slides and as we proceed through the lesson. It should always be present in your mind that whatever device we're talking about could potentially provide evidence. Where appropriate, I will try to interject scenarios in which this hardware could potentially provide evidence of your crime. This isn't always the case. There are times where we're just merely making mention of hardware for the sake of giving you an understanding. But again, where appropriate, I will mention those areas that potentially hold evidentiary data. You can see on this slide that hardware varies. There's a great deal of hardware that we encounter. Basically, when we describe hardware, we describe anything that's tangible. If you can pick it up and it's connected to a computer system and you can touch it, generally speaking, it's hardware. It's important for us to conceptualize and to understand this terminology when we're writing our seizure reports, when we're accounting for the list of evidence that has been seized, that we classify things as either hardware or application software. Again, as I said earlier, any functional, tangible part of a computer system is generally considered hardware. If you can hold it, if you can pick it up, it's probably hardware. Some examples: the system unit, which is what many people refer to as a CPU, but that's probably incorrect. The system unit is the box, the basic unit, the computer, whether it's a laptop case, whether it's a desktop, whether it's a tower, that's the box, that's the system unit. Then we have the monitor, the keyboard, the mouse that's attached to it, a printer, a scanner, all those things are considered hardware. We're also going to delve inside that box, inside that system unit, and we're going to talk about the components, the hardware components that are inside that may provide some evidence of a crime, may provide some evidence that helps our investigation. Hardware gets its instructions from what to do from the operating system. We'll talk about the operating system in another section within this webinar, but it's important to understand from the outset that in order to interact with hardware, we need an operating system. If you're using a Mac, well then Mac is your operating system. If you're using a PC, then most likely Windows is your operating system. And there's another operating system that's pretty common on the market, but again, we'll deal with that in the operating system section. The system unit. You could see several examples of system units within this slide. The system unit is the form factor, the case, that contains all the components that make up the computer. When we seize this device, it's important that we refer to it correctly. Within the system unit, there is a CPU, and we'll talk about the CPU, but the system unit is not the CPU. Within the system unit, there is a hard drive, but the system is not the hard drive. The hard drive is not known as the entire system unit. Many people use these terms interchangeably and erroneously. It's important that when we refer to an item seized, that we're all speaking the same language. So in this regard, we're talking about the physical box, whether it's a tower or a laptop. That's the system unit. Again, we don't want to generically refer to the CPU, the hard drive. We want to make sure that we are discussing a system unit. We can further describe that system unit in our seizure report or when we're testifying, but it is a system unit. So if it's a laptop, it would be a system unit, laptop style. If it's a desktop, it would be a system unit, either tower or desktop style. But you kind of get the picture now. Within the system unit, there is a CPU. The CPU is an acronym for Central Processing Unit. When we examine some of the terminology in computers, it's really helpful to take a literal approach. When the geeks designed this stuff, they really gave it names that apply to what it does. So if we break down this acronym, Central Processing Unit, well, that's exactly what's going on. This is a chip that's within the computer system unit that's contained on the motherboard, we'll talk about the motherboard in a second, that processes all the data. It sort of acts as the traffic cop. It's the one that all the data runs through. It is the central processing unit, the center of all processing within the computer. One of the best ways to appreciate this is kind of thinking of it in terms of a Sunday circular, if you will. If you pick up your Sunday paper and you're looking for a new computer and you read something about Intel Dual Core, Intel Pentium chip, that is your central processing unit, and that's where all data flows through. And you can see on this slide, I have an example of what that CPU looks like. The CPU is also often thought of as the brains of the operation. Now again, you've seen some examples, some pictures on slides that we have in this presentation, but you'll also see some real life examples that Dr. Doherty will present during his presentation as well. Random access memory is the primary working memory of the computer system. All things that are operating within the computer system, whether it's Microsoft Word, whether it's Microsoft Excel, are technically running in RAM, random access memory. RAM is a very important function within our computer system. It will become even more important when we talk about seizing electronic evidence later, because what's happening in RAM is really only temporary. It's only for the life of the computer. And what I mean by that is, as long as the computer's powered on, RAM is functioning. However, the minute we take power away from the computer, we shut it down or we pull its plug, whatever was in RAM is now gone. Certain things, certain evidentiary data may only exist in RAM. And so it's important when we approach the running computer system later that we keep in the back of our mind, oh, that's right, there's RAM in the computer and it may contain data that if I pull the plug here, I may lose. When we discuss seizure later and we discuss the taking of electronic evidence, I'll give you specific scenarios that outline when we should not approach a system and merely pull the plug, but rather maybe call a forensic expert to acquire what is in RAM before we take power away from it. Again, going back to our Sunday circular, you may see in the Sunday circular 1 gigabyte of RAM, 4 gigabytes of RAM. That, again, is temporary processing memory, memory that the computer uses to process your data as you're working. Once you save it, it goes to a different location, which we'll discuss in a second. But it is volatile. That's the most important thing to take away from here. RAM is volatile. It needs power to survive. Read-only memory. There's a chip on our computer that contains certain information. It's on the motherboard again, and you'll start to see the common theme here that everything is connected to the motherboard, but I'll get to that in a second. But there is a chip on there known as the ROM chip, the read-only memory chip. When Dr. Doherty presents later the boot process of this computer, he'll talk to you about the ROM chip and its role. The only thing I'll say about it here is it contains certain information that's important to us from an investigative standpoint. That information is some of the hardware that's contained within the system, the boot order of the system, how the computer boots, and you'll understand that again a little bit later, and that's important from an investigative standpoint at times. Most importantly, probably, the date and time of the computer system. In order to put things in proper context, we need to know what date and time that computer is set to. If it's set 3 days earlier, well, that changes the results of our forensic analysis later. So the ROM chip is the one that's responsible for holding that information, the date and time information. It does so through a program known as the BIOS, Basic Input-Output System. And again, you'll see some of that information on this slide, but Dr. Doherty will delve into that a little bit later. You've heard me allude to the motherboard, everything being connected to the motherboard. Again, if we go back to sort of geek speak for a second, the motherboard is the mother of all boards. It is the central board within our computer system. I've already stated that the CPU is attached to it, the RAM's attached to it, the BIOS chip is attached to it. So here's the rule. Anything that needs to communicate with this computer, anything that the computer is going to use, a keyboard, a mouse, a printer, a wireless network card, a wireless router, needs to connect to the motherboard in some fashion. The motherboard brings everything together. And we'll talk about a little bit how that happens, but the motherboard is the central part of this computer system unit. It's contained within the system unit. It's contained within that form factor. A laptop has a laptop motherboard. A desktop has a desktop motherboard. Every computer system, generally speaking, has a motherboard. Regardless of where it's located or what kind of form it comes in, the motherboard is the one that brings it all together. Within that motherboard, on that motherboard, there's a complex network of wires that run through it. This is known as our system bus. The system bus is merely a pathway of imprinted wires that passes data. This is a good time to introduce really the fundamental core of a computer system, and that is data. That's what we're about. When we're using a computer system, we're about processing data. Whether it's data we're going to store or data we're just going to view, say on the internet, we're about processing data. And that's what the motherboard does. It processes data. At a very, very, very base level, data is just merely a matter of combining ones and zeros, electrical impulses, ons and offs, if you will. Without getting too technical on you, we just need to understand that anytime we look at a picture, anytime we type a document, that picture is merely comprised of a combination of ones and zeros. And it's those ones and zeros that are interpreted by the computer that make up that picture or that document or whatever else we may be doing in a computer system at that time. We need a way to communicate those ones and zeros, to send it off to RAM so we can have it stored there, to pass it through the CPU, the central processing unit, so it can be processed and know where to go and know how to be rendered, to store it for later usage. maybe on a piece of external media, which we'll discuss in a second, or a hard drive, which we'll also discuss. At a very base level, the computer system is merely dealing with ones and zeros, and those ones and zeros need a way to communicate throughout the system, and that's through this network of wires that's imprinted on the board known as the system bus. The expansion bus, again, is what the name implies. It allows us to expand the capability of our computer system. Now on a laptop, it's handled a little differently. But on a desktop, right on the motherboard, you can see in this slide, there are various slots in which we can plug in expansion cards. Perhaps we want 2 monitors connected to our computer system, but we only have 1 monitor connection. Well, we could add an expansion card to put in a second monitor and add a second monitor connection. Or perhaps we're going to use the computer system to play our music, our MP3 files or our CDs, and we want to add greater sound capabilities, greater output for our speakers. We could then plug a sound card into our expansion bus and increase the capabilities of this computer system unit. If we want to increase any capability, generally speaking, we're going to attach it to our expansion bus. Here we see some examples of some of the expansion cards. If you notice from the previous slide, those slots accommodate the printed part of the circuits down on these boards. It's important that when we seize devices that we take a look at these expansion cards. Basically, we could see them on the outside of the computer system. We don't need to open it up to visualize them. But by doing this, we get a good idea, especially if we take a picture of it before we seize it, we get a good idea of what was connected or what could be connected to this computer, which may indicate other devices that we need to be vigilant for or that we may need to seize. To further enhance our ability to connect computer system components to our computer, we have input-output ports. Back in the old days, we used to use parallel ports and we used to use serial ports. Many of these computer systems still have parallel and serial ports, but the rule of thumb today is that most devices are connected either via a USB-B port, which stands for Universal Serial Bus, or a FireWire port. Without getting too technical on you and without delving into how data is transferred between these ports, what's important to realize is these ports need to be checked. I have some examples of the ports here on a laptop and on a desktop system, and you could certainly take a look at your own computer systems to see where some of these ports may exist. It's important to check these ports and be familiar with them because other devices may be connected to them. External hard drives that contain evidentiary data, external DVD writers that may contain data written to a DVD that we need to be aware of, a wireless network card that we didn't know that they were connected to the wireless network where we may need to look for further computer systems or a wireless router. So by merely accounting for these ports and seeing if anything's plugged into them, we'll pretty much accomplish our goal. This slide is just merely meant to familiarize you with what those ports look like. The hard disk drive is the primary storage unit within our computer system. This is where the data goes. Basically, there is usually a primary hard disk drive. It's where our operating system resides. It is where all of our data and our files are stored. This is probably the most important part of the computer system from an evidentiary standpoint, putting aside the RAM. The RAM may be the most important part in certain instances. The hard drive is usually contained within, but we can also have external hard drives as well. This slide talks to you a little bit about how data is written to a hard drive, but that part's not necessarily overwhelmingly important for you to conceptualize. It's more important for you to understand that this is where the data is. In this slide, we see several examples of external storage devices, where data can be stored outside the computer. Yes, these devices need to be connected to the computer in order to transfer that data, but once they are connected and then disconnected, they can be anywhere. And you can see some of these devices are no bigger than a postage stamp, making the ability to hide data relatively easy. So we need to be vigilant when we're searching for these devices. The most important thing you can take away from the recognition here is that there's data out there, and there could be data on these devices that's extremely important to our investigation. And we need to try to account for as much as possible and find and locate these devices. Some of it gets tricky. My recommendation is that as a sort of a follow-up, do a Google search for USB thumb drive, USB flash drive, external hard drive, then switch over to the images section and get an idea of the form in which some of these come. Sometimes a USB thumb drive is hidden in a pen. Sometimes it's hidden in a toy. Nevertheless, it can plug into your computer and store data, and we need to be aware of that. Optical media, DVDs, CDs, have the potential to store data. That's what we use them for. We usually use them for system backup, for our music, for our movies, but they can store any type of data. And again, this is something that should be subject to seizure if we're executing a search warrant or a consent search and we need to account for all the data. We want to take these devices and have them analyzed by a forensic analyst. They are easy to recognize. Most everybody is used to dealing with them. What's also important to realize about optical media is the high capacity potential that they have. We can store a great deal of data on a DVD. Unless you're in a business environment, you may not have occasion to see tapes. Tapes are used for backup and archiving of data. Companies, generally speaking, will put their data on a server, on a file server, a central location where all data is stored. In order to protect their data in case of system failure, power outage that corrupts a system, any type of mechanical malfunction, they usually back up to tape. What's important to realize about tape, tape can provide a window into the past. For argument's sake, a company accused of a crime maybe gets a little nervous and knows law enforcement's coming. So they delete the data off of their servers. Maybe they wipe their servers entirely, but they forget their tapes. Again, the tape can provide a window into the past. It's going to contain data, more than likely, and it's something that should be analyzed. I'm going to spend about 10 seconds on this slide because we don't see floppy disks anymore. But I put it there for those of you who may be new computer users, aren't used to seeing floppy disks, but may still encounter them. Every once in a while, I'll still enter a crime scene or I'll go into a location and come across floppy disks. They don't store much data, but they can be used to store the data that might be important in your investigation. And again, if it stores data, we want it.